IO-Link is a communications protocol that works point-to-point. A point-to-point communication connection is a communications connection between two separate endpoints or nodes. IO-Link is bidirectional, meaning it works two ways and works over a short distance. It is primarily used to communicate with sensors and actuators in factory or plant automation processes. Sensors and actuators are usually connected via a field bus connection, allowing them to be in remote locations. With IO-Link, the field devices such as actuators or sensors connect to a master device which communicates with a controller, which is usually a PLC or a programmable logic controller. The connection between the IO-Link master and field device is established via an unscreened 3-wired cable no more than 20 meters long. The IO-Link master is capable of processing digital signals and analog values. Its versatility means it's capable of integrating into existing systems and can communicate using the industry-recognized Profinet, Profibus, or Modbus, to name a few. The IO-Link master establishes the connection between the IO-Link devices and the automation system. As a component of an I/O system, the IO-Link master is installed either in the control cabinet or as remote I/O directly in the field. The IO-Link master can have several IO-Link ports or channels. An IO-Link device can be connected to each port, meaning IO-Link is a point-to-point communication and not a field bus. The IO-Link protocol allows an IO-Link port to be operated in one of 4 operating modes. The first operating mode is IO-Link mode. This means that the port is used for IO-Link communication. The second mode is DI mode. This means that the port acts the same as a digital input device. The third mode is DQ mode. This means that the port acts in the same way as a digital output device. The fourth mode is deactivated. The port is not assigned to any other mode and is reserved for when the port is unused. IO-Link is a very robust communication system that operates using 24 volts. Transmission errors can occur for a number of reasons. In general, a cable fault or a power surge can temporarily interfere with transmissions. If an error is detected, the message attempts transmission up to an additional 2 times. Only after the transmission has failed for a 3rd time does the IO-Link master recognize a communication failure. Upon recognizing this, the IO-Link master will signal the communications failure to the higher level controller. This can then alert operators or maintenance staff of the issue so they can physically attend to and rectify the problem. An IO-Link device has 4 types of transmission: process data, value status, device data, and events. Process data is considered as the latest state of the sensor or actuator, such as speed. Process data is transmitted cyclically, which is automatically and at a regular defined interval. Up to 32 bytes of process data can be processed, and is defined by the high-level controller. The value status indicates whether the process data is valid or invalid and is transmitted along with the process data cyclically. Device data holds detailed information about a device. Basic information such as serial number or version number, and more advanced information such as parameters or diagnostic information are able to be retrieved from each IO-Link device. Device data is transmitted acyclically at the request of the IO-Link master. This means that it is not automatically transmitted, but will be transmitted after a request from the IO-Link master. Device data can be read from the device, but can also be written too. A device is able to trigger an event, which in turn signals the presence of an event to the IO-Link master. An example of an event is an error or warning message. For example, a short circuit, or a device that is overheating. This information can be used to display indicators or messages on HMI devices, such as error messages signaling a wire break or communications failure, once the IO-Link master has processed the message to the high-level controller. The transmission of device parameters and events occurs independently from the cyclic transmission of process data. This means that they do not impact each other, so critical messages do not have to queue until already buffered messages are sent. So let's summarize what we've learned. IO-Link is a simple communications protocol. It is used primarily for communications to simple 3-wire sensors and actuators. An IO-Link master has slave devices such as an actuator or sensors attached to it. The IO-Link master can then communicate over a field bus connection to the higher level controller, most likely in our case, a PLC or programmable logic controller. The IO-Link ports can serve different purposes, from signaling that is unused to signaling that is in input or output mode, or for IO-Link communication. An IO-Link device transmits process data and value status periodically at a regular defined interval called cyclic transmission. And finally, device data such as diagnostics and events are transmitted when they are needed. This is called acyclic transmission. Thank you for watching our Industrial Internet of Things educational video. See you in the next one.